record on this computer. Yeah. Parallel and perpendicular most about the horizontal line y is equal to -1. Okay. Yeah. Now we'll see. Where is this? Polar coordinates later on. Okay, first just keep writing as volumes of solids. Volumes of the solids. Volumes of solids. Suppose if I have a solid, some different figure. I need to find volume of this. So what I'll do, I'll divide them into small discs. You can see discs here, right? I'll try to divide them into small discs, multiple discs. So hundreds of discs I'll try to divide. So we know volume is, each disk is pi r square, pi into integral of r is f of x whole square here, pi into f of x whole square into dx, where is a to b, if you are doing with respect to x. Same thing if you are doing with respect to pi into integral of a to b, f of y whole square into dy, which you need to remember. So if you are using disk method, you are converting the given object into multiple small disks. So the volume is pi into integral of a to b f of x whole square into dx, or pi into integral of a to b f of y whole square into dx. We'll do some questions. There are 3 response questions here also. We'll do them. You'll understand. So I'm just giving 1 or 2 questions on this. Just see here. Find the volume of the solid. Find the volume of the solid bounded by the lines. Bounded by the lines. X is equal to 0. X is equal to 2. And curve y is equal to x square rotated about x-axis. Rotated about x-axis. First, see the question that is asking. Find the volume of the solid bounded by the lines x is equal to 0, x is equal to 2, and the curve y is equal to x square rotated about x-axis. So he's asking us to find the volume. Okay? Yeah. So first draw the figure that is asking for. So this is x is equal to 0. This is x is equal to 2. This is the graph of y is equal to x square. So this is rotated about the x-axis, means you get a volume like this. So now these are squares. Sorry, these are our discs, like circles. So integral of pi into integral of 0 to 2. So f of x whole square into dx. So what is f of x? X square. So x square whole square into dx. Do that, that will be your answer. So if you are able to divide into disk, pi into integral of a to b, f of x whole square into dx. I'll do 2-3 more questions, and I'll do even actual questions. In free response questions, generally you get these models, either parallel or perpendicular, rotated about x-axis, or rotated about the line x is equal to 1, rotated about the line y is equal to 1. Now let us do a next question. Find the volume of the solid bounded by the lines x is equal to 0, y is equal to 1, y is equal to 4, and y is equal to x square rotated about y-axis. Rotated about y-axis. Rotated about y-axis. Rotated about y-axis. First, draw the figure x is equal to 0, y is equal to 1, y is equal to 4, and y is equal to x square. So this is y is equal to 1. Sorry, this x is equal to 1, right? So this is x is equal to 0, y equal to 0, y equal to 1, y equal to 4, y is equal to x square. This is the figure. So now this one, this is the y is equal to x square, rotate about y-axis. So this is your y-axis. So you get shape like this, like this, like this, like this. So I'll draw a new figure again here. X is equal to 0, y is equal to 1, y is equal to 4, and y is equal to x square, and y is equal to x square, rotated about y-axis. So now first draw the figure. So this is your x is equal to 0. This is your y is equal to 1. This is your y is equal to 4. This is your y is equal to x square. So this is the figure. So this is rotated about y-axis. So if you rotate it about y-axis, so what do you get? So you get this. So this is the one figure. This is the other figure. This is the other figure. So this disc, you can see here this. So pi into, now we are taking y limits. Y is equal to 1 to 4. Integral of 1 to 4. Now you need to write f of y, means x is root of y. Y is f of x. You should write in terms of x, root y, which is whole square into dy. So you do simplify this, you get the answer. So using the disk method, we have two formulas: pi into integral of a to b f of x whole square into dx, or pi into a to b f of y whole square into dy. Either of them we can do. Pi into integral of a to b f of y whole square into dy. Okay. So if you simplify, you'll be able to get to the answer pi into integral of y, which is y square by 2, which is from 4 to 1. So pi by 2, 4 square minus 1, which is 15 pi by 2 cubic units. This should be your answer. 15 by 2 cubic units. That should be your answer. Okay. Yeah. I'll give you next 1 or 2 more questions on this. Then we'll do actual questions based on this. So the next question is, I told you, right? We can also do around x-axis, y-axis, or around the horizontal line x is equal to 1. Next question. Find the volume of the solid formed. Find the volume of the solid formed. Find the volume of the solid formed by the curve y is equal to root x on the lines x is equal to 1 and x is equal to 4. All these are actual questions. I might just have modified small change in values, but the questions are rotate about the line y equal to 1. Rotated about the line y equal to 1. Just see this question now. Rotated about the line y is equal to 1. Draw the figure. Try to do. If you cannot do, I'll do. I'm giving you 1 or 2 minutes. You just see. So you can rotate about x-axis, y-axis, x is equal horizontal lines and vertical lines. Both ways you can do these questions. Okay, so people have been trying. Okay, so first see the conditions that I'm drawing the figure this side. You can be able to see. I gave the found by the lines x is equal to 1, x is equal to 4, found by the curve y is equal to root x, this is y is equal to root x is equal to 1, this is x is equal to 0, so this is x is equal to 1, this is x is equal to 4, rotated about the line y equal to 1. This is the line y is equal to 1. This is your function root x. This total length is root x, but I need rotate about the line y means this one off. You might get figure like this entire thing. So the radius would be root of x minus 1. You need to observe that. So pi into integral of 1 to 4 root of x minus 1 whole square into dx. Before I have done root x whole square because I rotated about the line x-axis, that is y equal to 0. But now here I'm rotating with the line with respect to the line y equal to 1. So if you rotate with the line with respect to y is equal to 1, the volume that is formed is pi into integral of 1 to 4 root of x minus 1 whole square into dx. Pakka, you get question on this in your advanced placement exam. You might even get multiple choice, but in free response also frequently see. Now there are so many questions. I'll just scroll down to the above. You'll be able to see. Now anyone can do. Who knows basic formulas, they'll be able to do. But getting to this step is important. So pi into integral of a to b f of x whole square dx is the formula which you should be using this to solve. I told you about x-axis, y-axis, horizontal line. Now I'll also give a problem based on the vertical line. So I'll be covering all the models related to this. Find the volume of the solid formed by next model. Find the volume of the solid formed by find the volume of the solid formed by the curve y is equal to x square minus 1 and between lines y is equal to minus 1 and y is equal to 3, rotated about the line x is equal to minus 2, rotated about the line x is equal to minus 2. Same thing, but they are rotating about the line x is equal to minus 2. Okay, let me draw the figure. You just draw the figure and find the volume that should be done. So if you see the question, so what are the conditions? Find the solid bound by the curve y is equal to x square minus 1. So x square minus 1, this is the graph of x square. X square minus 1 means it should be bottom. Between the lines y is equal to minus 1, y is equal to 3. So is also given y is equal to, this is y is equal to minus 1. This is y is equal to 3. Rotated about the line x is equal to minus 2. So I'm rotating about the line x is equal to minus 2. So pi into integral of minus 1 to 3. So what is your function? x, right? X is root of y plus 1, right? So root of y plus 1 is this plus 2, because this is rotated about the line minus 2. This is root of y plus 1 plus 2. Root of y plus 1 plus 2 whole square. Root of y plus 1 plus 2 whole square. Root of y plus 1 plus 2 whole square into dy. You just need to find the radius. Pi into f of y whole square into dy. So what is your f of y is important here. F of y is root of y plus 1 plus 2 whole square into dy. To simplify, whatever is the answer, that should be your answer. You can expand, then do integration. You can also use calculator. This will be generally these will be calculator based questions. Disk method is important. I frequently see questions coming on disk method. After I'll do washer method also. Then I'll do actual questions that have come as part of the exam. Then if see washer method, when do we generally use washer method? So assume I have a function and I have another function. I can see a washer here. So if I need to find the volume, this volume, if this function is f of x, let this function be g of x, let this function be f of x. So volume is given by pi into integral of a to b f of x minus g of x whole square into dx. Volume is given by pi into f of x whole square minus f of x whole square minus g of x whole square into dx. So yeah. So volume is given by pi into integral of a to b f of x whole square minus g of x whole square into dx. Similarly, you can also find with respect to y pi into a to b f of y whole square minus g of y whole square into dx dy. F of y whole square minus g of y whole square into dy. F of y whole square into g of y whole square into dy. You see, whenever there are two functions, either if they are rotated about x-axis, y-axis, or about the line, then you get a washer. But you need to have a two functions. Unlike before, I have a single function. I'm rotating about the line x is equal to 0 or y is equal to 1. A single function I am rotating. But now I'll have a combination of two functions. The two functions will be rotated about either x-axis or y-axis, or about the line x is equal to 1 or y is equal to 1. Now let me see few examples. Let me start with the basic question. Find the volume of the solid generated by y is equal to root x and y is equal to x about around x-axis. Find the volume of the solid generated by y is equal to root x and y is equal to x around x-axis. So first let me draw the functions. This is y is equal to x. This is y is equal to root x. There are two functions here. What I'm doing, I'm rotating with respect to x-axis. So you get a volume, something similar to this. They're rotated around x-axis. If you see, this is the outer and this is the inner. This is the outer, this is inner. So volume is given by 5 into this is where the point where both the curves are intersecting, both the curves are intersecting, x is equal to root x squared on both sides. X square is equal to x. Bring this side. X square minus x is 0. Take x common. X into x minus 1 is 0. So x is equal to 0 or x is equal to 1. So this is 0. This is 1. So pi into integral of 0 to 1. So if you can see the upper curve is root x whole square minus x square into dx. So whenever you have two functions, if you have two functions and the function is reflecting with respect to x-axis or y-axis, you need to use washer method. And this is what is the answer for this question. So simplify, you'll get the answer. First, drawing the figure and getting to the answer is important. So once you understand, it's simple. You just need to know the formula, disk method or washer method. Okay. Yeah, I'll give one or two questions. We'll see. Find the volume of the solid, then we'll do actual questions. Find the volume of the solid. Find the volume of the solid obtained. Find the volume obtained by rotating y is equal to x and y is equal to x square minus 2x around the line y is equal to 4. Around the line y is equal to 4. Draw the figure. The moment you draw the figure, you should be happily able to solve the questions. So if you draw the figure, you get two functions, you'll understand it is a washer method, then you can happily plug in pi into integral of a to b f of x whole square minus g of x whole square in dx, or f of y whole square minus g of y whole square in dy. You'll be able to realize, but you draw the figure. I'll give 1 minute, you solve. If not, I'll solve it on there. Okay, draw the figure here. If you draw the figure, you'll be happily able to do this. Draw the figure y is equal to x. Draw the figure x square minus 2x. So if I want to draw x square minus 2x, so vertex is 1 comma minus 1. So 1 comma minus 1 when x is equal to y equal to 0. So it should be something like this. So they lead definitely at 0 comma 0, and they also meet at x is equal to 3. Yeah. So 3 comma 3 and 0 comma 0 are the 2 points where they meet. And if you see the question, rotate about the line y is equal to 4. Here somewhere around, this is 3, right? So here y is equal to 4 is this. Rotate about the line y is equal to 4. Now if I see this minus whole square minus this. So 4 minus of x square minus 2x whole square pi into integral of, if you see y limits, x limits 0 to 3, this is 0, this is 3, into 4 minus of x square minus 2x whole square minus 4 minus x whole square into dx. So this is 4, this is x, so this will be 4 minus x. This is 4, this is x square minus 2x. So this curve is 4 minus of x square minus 2x whole square. So 4 minus of x square minus 2x whole square minus of 4 minus x square into dx. In your engineering, what you do here is nothing. You do multivariable calculus, high level math you do here. The basics, if you know basic, you can happily able to do these questions. Okay. Yeah. Now we'll do few questions, actual questions that are there. We'll do them. Okay, good. So some of you are giving me, typing me the final answers. Very good. But you should also know, generally it also comes in calculator based thing, which I generally see. So which you should know. No. I'm moving on. You can see here volume questions. I saw many volume questions here. Yeah, you just do this. If you can do this, most of the things are being covered here. First, you need to find area under the curve. Integral of a to b f of x minus g of x into dx. This is a calculator based question because it is not so easy to simplify. 4 minus 2x is equal to x cube by 1 plus x square. Even your math genius, it is very difficult to do that. Yeah, tomorrow 68. Yeah, normal time. Next 4-5 classes I'll complete. Then you can practice. You need to practice. Even I'll send you multiple choice questions, everything you can practice here. Soon I'll send you. So find the area of the region R. I want someone to tell me what is this point of intersection. I cannot calculate. So how do you find point of intersection? So 4 minus 2x is equal to x cube by 1 plus x square. You need to use your calculator. This is a calculator based question. So solve this equation. You can draw the graph of this, get a graph similar to this, and you can see the point of intersection. But he has given here, no? Yeah, he has solved and he has given. Even if you solve, you need to get around 1.48 or 1.49. Keep like this only 1.487. At least to 3 decimals, you need to take the point to get the correct answer. So area under the curve is integral of a to b. So this is 0. This is 1.48, whatever he has mentioned. Integral of 0 to 1.487 something. So what is this? Upper curve minus lower curve. So 4 minus 2x minus x cube by 1 plus x square into dx. This minus this into dx. It is going to give you the answer as. Understood, right? Yeah. Now volume. Find the volume of the solid generated when R is revolved around the x-axis. So you are revolving around x-axis. This one. So you get a washer. So pi into integral of outer curve, which is 4 minus 2x whole square. So integral of a to b 0 to same 1.487 f of x whole square minus g of x whole square. See how simple if you know the concept. You are rotating about this, so you get a washer. Pi into integral of 0 to a f of x whole square minus g of x whole square into dx. Next, let R is the region of the base solid. For this solid, each cross section perpendicular to the x-axis is a square. Perpendicular to area of the pi perpendicular to x-axis is a square. You need to find this length. How do you get length? This is 4 minus 2x. This is this. So this minus this will give you this length. So integral of area under the curve. So 0 to a f of x whole square into dx. 4 minus 2x minus of x. That is what he has given by whole square into dx. We did yesterday. Parallel and perpendicular. Volume is integral of area. Area of the square is a square. So 4 minus 2x minus of x cube by 1 plus x square whole square into dx. That is how we are going to get to the answer. Correct, right? Yeah. Now we'll see. Please do all these questions. Since solutions are there, it will not become such a difficult part. Please do all these things which will become easy for us. Just solve one question on your own. Yeah. This is a recent one. 226. 226. Distance. 227. I think yesterday I did that. No, I did not do this. So it is all same as what I explained it to you right now. This I think I explained yesterday. Same thing. This I explained yesterday as it is question. So try to do this one. Answers are there. Please don't see the answers without looking at the answers. You just give me the solution. We'll also do this or is this other topic so that it could be done. I'll do motions. Particle motion. We'll do that right now. Please do see solve the solutions without looking at the solution. You just see and verify the answer. You get to the answer. Very good. Very happy. So please do this one. and we'll discuss next topic. Riemann sums, intermediate value theorem, everything I discussed with you. Taylor polynomial, power series, mean value theorem, parametric equations, arc length. Okay, we did right. Find the area of the curve. Find the point of intersection. 0 is 1, x is equal to 0, x is equal to 2. So upper curve is y is equal to x, lower curve is x square. So integral of 0 to 2x minus x square dx, that will give you the area. Volume is, the region R is a basal solid. For the solid, each x cross section for x-axis area. He has already given area, such a good person. So cross section perpendicular to x-axis and area is sin pi by 2x. So area is integral of a to b, which is 0 to 2, area into dx sin of pi by 2x into dx. Another solid has the same base R. For the solid, the cross section perpendicular to x-axis are squares. Integral expression. So now he's asking with respect to y-axis. So with respect to y-axis means x is root y. This is root y. So this is y by 2. Correct, right? This is root y. This is root y. This is y by 2. So root y minus y by 2 whole square into dy. Integral of this is 0. This is 0, 4. 0 to 4. So another solid has the same base R. For this solid, the cross section is perpendicular to the y-axis are squares. Perpendicular to the y-axis are squares. So upper curve minus lower curve, which will be perpendicular to the y-axis, root y minus y by 2. Area would be y by 2 whole square. So you'll be able to do them. Okay, perfect. Here, this is all you will do. Just 1 second. So volumes you will do now. Volumes question. So either parallel or perpendicular, disk method and washer method. You are going to get questions from these. Please do solve them carefully so that you will be able to do any question which is related to that. Yeah, polar coordinates I require next entire class. We'll be doing this polar coordinates vectors also will do. Sequence and series, 1-2 classes, most important sequence and series. This I'll do integrals BC. Okay, you know how to calculate integrals. This is okay. So sequence and series, polar coordinates. Then I give some question papers. Okay, next 3-4 classes there, everything will be done. Motion of the particles that we need to do. We need to do just motion, particle motion, sequence and series, and the polar coordinates. So if you do this, whatever is required for this topic should be done. Correct, right? Yeah. So just keep it as parametric equation. Parametric equations. Just keep it as parametric equations. Polar coordinates I'll do. First, you need to know about parametric equations. So just keep it as parametric equations. So generally we draw graphs between x and y. Algebraic functions, right? Which are very easy. So it is not always convenient to represent every function in terms of x and y. So representing a function x and y in terms of a third variable, generally called theta, is called parametric equation. And the third variable is parameter. So generally we represent x and y in terms of theta. Theta is the third variable, which is a parameter. So we call it as parametric equations. So not only theta, we can have anything. Suppose if I have a function like x is equal to t square minus 4 and y is equal to t by 2 or minus 2 less than or equal to 2 less than or equal to 3. So what I'll do? This is my x, this is my y, this is my t. I'll do -2, -1, 0, 1, 2, 3. For different points, I'll find the values of x and y. So put -2, 0, put -2, -1, put -1, -3, put -1, -1/2, 0, -4, 0, 1, -3, 1/2 to 0, 1, put 3, 9 minus 4 is 5, and 3/2. So 0, -1, when x is equal to 0, y is -1, this is 1 point. When x is equal to -3, y is equal to -1/2, this is the other point. When x is equal to -4, y is 0. Am I reading correct? Yeah, -3, comma. So when x is equal to -3, sorry. So if I try to graph a point, yeah, when x is equal to 0, y should be -1. When x is equal to, sorry, when x is equal to -3, it should be -1/2. When x is equal to -4, it is 0. Yeah, sorry, 1 second. Let me find the equation relation between these two. X is equal to t square minus 4 and y equal to t/2. So I am replacing t with 2y. So x is equal to t is equal to 2y, right? 4y square minus 4. Okay. Yeah. So the equation would be x is equal to 4y square minus 4. So x is equal to 4y square minus 4. This is the equation, which is the parameter that represents. So if you want to draw, you need to draw a relationship between x and t and y and t. So if at all you want to find the graph between these two, when x is equal to 0, y is -1, correct, right? When x is equal to -3, it is becoming like -1/2 and -0. So if I try to draw the graph of x is equal to 4y square minus 4, so we get a graph something similar to this, the 4y square minus 4 parabola, stuff like this. This is what the graph we get. Generally, they don't ask you to graph and everything. We need to form the relationship between x and y. When a parameter is given, we need to eliminate that parameter and try to graph it. You can use your calculators to draw the parameters if at all they had given any thing. Suppose if they give me like x is equal to 2 root t and y is equal to 3t square minus 2t. So what are the different questions they can ask? First question is they can ask you to find dy by dx. You are very well how to find dy by dx. You'll do dy by dt and dx by dt. They might ask you to find d square y by dx square. So if they ask you to find d square y by dx square, d by dx of dy by dx. So d square y by dx square is d by dx of dy by dx. You know what is dy by dx. Once you find dy by dx, whatever the function you get, suppose if I have dy by dt by dx by dt. So what is dy by dt? 60 minus 2. What is dx by dt? 2 into root t is 1/2 root t. So you get root t into 60 minus 2. So this is your function. So they'll ask, I can ask you find dy by dx when t is equal to 1. If I ask you to find t equal to 1, you get answer as 4. Now I'm asking you to find d square y by dx square. So d by dx of dy by dx. So what is dy by dx? Root t into 60 minus 2. So UV rule, root t into d by dx of 60 minus 2 plus 60 minus 2 into d by dx of root t. So you'll get root t into 6 will come out dt by dx, which is 0, plus 60 minus 2 into derivative of root is 1 by root t into dt by dx. You know what is the value of dt by dx? They gave x. So dx by dt is 2 into 1 by 2 root t, which is 1 by root t. So dt by dx is root t. So you'll plug in dt by dx here. So d square by dx square is not easy. You'll get confused. So they give a parameter and they ask you which of the following is equal to d square y by dx square, which we need to be careful. So we know dt by dx. What is dt by dx? Root t. So you can plug in root t and finally replace t equal to 1. You'll get the answer. So generally parametric equations, what are the types of questions generally you can get is they'll ask you to find, they give a parameter in a third variable, they can ask you to find dx, dy by dx or d square by dx square, or they can ask you to find the equation of the tangent line at particular point. For example, the next model that I see is, I'm giving a function x is equal to 4 cos t and y is equal to 3 sin t. Write an equation of tangent line curve at the point t equal to 3 pi by 4. When t equal to 3 by 4, I need to find the equation of the tangent line. So first find the coordinates of x and y, then find dy by dx, which is same as dy by dt and dx by dt. So in the parametric equation, the next model which I can see is finding the equation of the line. So you can find dy by dx using these two formulas. You get some slope. So you'll get the values of x and y. So y minus whatever the value I get here into whatever the slope I get here into x minus this one, x1, which will give you the equation of the tangent line. Okay? Yeah. Now, yeah, these are most important. These two formulas you write, then I'll close the thing. So in they give a parametric equation and they ask you to find the length of the arc. So if they ask you to find the length of the arc, it's given by integral of a to b square root of dx by dt whole square plus dy by dt whole square into dt. This is the formula for the length of the arc. So length of the arc in parametric equation is frequently they ask dy by dx or d square by dx square, or they can ask you to find the equation of the tangent line, and they can also ask you to find what is this? Length of the arc. In parametric equation, they'll also ask you to find length of the arc. And generally, I also see they'll ask you same in parametric equation. They can ask you position vector. Position vector is generally given as x of t comma y of t. They can ask you to find velocity vector. Velocity vector is given by x dash of t comma y dash of t. They can find acceleration vector, which is x double dash of t comma y double dash of t. In parametric equation, they can ask position, velocity, acceleration. They can also ask you to find speed. Speed is modulus of velocity, right? So which is square root of x dash of t whole square plus y dash of t whole square. That will give you the speed. Okay. So generally, these are the questions that they ask based on the parametric equation. So whenever you have a parameter, these are all the different models. dy by dx, d square by dx square, equation of the tangent line, position vector, velocity vector, acceleration vector, and length of the arc. So these are the formulas that you get based on this year. I think few questions are based on that. So you can please do practice. Tomorrow I'll come from, I need 3 more hours. 68 if I have 1 more hour. Yeah, mostly 3 more hours. We'll try to complete everything. So tomorrow mostly we'll focus on sequence and series, power series, Taylor and polynomial series, everything. So tomorrow would be everything on sequence and series. Don't miss. 1 question would be there and 2 multiple choice questions would be there. I'll explain in detail how to solve them. So I'll see you tomorrow. Yeah, take care. Bye.